Let's work on the problem 6.16. For the unity feedback system, g of s is given as follow. Determine the range of k for stability. So this is the g of s, the transfer function. We have a unity feedback, so this is g of s, and then this is c of s, and then we have r of s as an input, and then there's a unity feedback right there. Therefore, if you want to find the t of s from here, we have ks squared plus 8ks plus 15k if you expand it. And for the denominator, we have a s squared minus 6s plus 8. Now, when you take care of this unity feedback, you need to add the numerator to the denominator. So that's the shortcut that we discussed in class. Then we have something like this. Now, for the denominator, we have k plus 1 s squared, and then plus 8k minus 6s, and plus 15k plus 8. So for the root table, we have s squared term that is k plus 1 and 15k plus 8, and s1 term we have 8k minus 6 and 0, s0 term 15k plus 8. For the stability test, so in order to be stable, we have the first column, they have to be all positive. Therefore, k plus 1 has to be greater than 0. And then 8k minus 6 has to be greater than 0. And then 15k plus 8 has to be greater than 0. So by looking at this from here, k has to be greater than negative 1. And from here, 15k is greater than negative 8. And k has to be greater than negative 8 over 15. And from the middle, we have 8k has to be greater than 6. That means k has to be greater than 6 over 8. So this is the case where for the stable, k has to be greater than 3 over 4. That's one. Now for marginally stable, we have to have a row of 0. Now we have options. Here is the row of 0, but we cannot do this. Okay, that's not an option. We cannot find the value of k will give us row of 0. So either here or here. Let's say we're going to use this S0 row as a row of 0. That means we need to go up by one row and use Ox equation. However, if we do that, the Ox equation is going to be 8k minus 6s equals to 0, right? Whatever value of k we plug in, there's no way we can have the j omega x's crossing because the s term is s to the power of 1. Therefore, we have to have row of 0 in here. Then the Ox equation is going to be, well, k has to be 3 over 4. So the Ox equation is 3 over 4 plus 1s squared plus 15 times 3 over 4 plus 8. That equals to 0. Then the Ox equation P of S is going to be 1.75s squared plus 19.25 equals to 0. This will give us 2 j omega x's pole. So marginally stable, we have to have a k equals 3 over 4. Unstable, k has to be smaller than 3 over 4.